And there is one part where we give you the results, but you just need to analyze them to give your thoughts about them. And for CAD 2, she will be just demoing it, showing you where the simulation netlists are, how to proceed with them, telling you what you need to collect for the homework. And then you can offline work on that. And then it will be due a bit later, يعني بعد بالأسبوع اللي بعده بعد after the short quiz. For CAD 3, she will release with it the requirement. Okay, sorry. Thank you, George. Thank you. I re-entered as a muted. Okay, and I was not the host from there. Okay, so so for the Canal CAD 3, we will be looking into the project material. So this will be next Wednesday. So all of you will attend. We are not going to split you into groups. Ma'an, can you hear me now? Ma'an, can you hear me now?
Yes, we can hear you.
Okay, thank you. Okay, so Lakena will
CAD 2 بس.
CAD 2 on Monday. It will be half a session. She will release the homework, and I will send you and we will load the instructions. So you don't have to try alongside with her, because we felt it is better that she records it and you try on your own. She will give you the net list and everything. For CAD 3, we will release the project material, so it will be Wednesday next week. It will be a full session. She will release the material, and it will be good if one of the team can attempt to try alongside with her, بس to get started يعني. ساعتها يعني not all of you have to log in. 30 people will have to log in. And this part of the project, you can get started from the files that she will give you. And one part, we give you the answers. You just need to do the analysis. Okay? بس حسب الشرح, the explanation that she will provide to you. So you all will attend the class time, and these will be released during a class time. No groups, no dividing. Monday, you don't have to try alongside. It will be recorded. Okay, and Tuesday and Wednesday, afwan, it will be for the project. يعني Monday half hour for the CAD 2 recorded, and Wednesday for the project. On Wednesday, if one of the team can have VLabs ready to try, then that will be great. Okay, so this is what we need to do now. Based on the explanation of this week on the inverter DC characteristics, I will release a small homework which will be due towards the end of next week, so that you will have some practice before يعني Monday اللي هو حيكون الويك اللي بعدها الشورت كويز. So حيكون عن ال DC characteristics of the inverter اللي هي how to solve for VOH, VIH, and understanding the transfer function, basic transfer function. Okay? فإذا next week we will get feed on CAD 2 and we will get feed on the project. CAD 2 will be due after the short quiz لأنه عندكم homework that is due. But I just wanted to release it لأنه it is important for the yes Ibrahim لأنه it is important for the discussion that will happen on Wednesday. يعني we had to release it in that fashion. So basically 29 is your next short quiz. It will be on the inverter DC, and 22 we will have CAD 2, which will be due after the short quiz, but it will be preparation for CAD 3, which is the project release اللي هي بتكون on the 24. Okay, so try to have one member of the team to attend on Wednesday, and I will send you email in this regard. حدا بعد عنده questions؟ طيب اوكي. Yes.
هاي بروفيسور.
هاي.
يس مرة قلتي لنا انه اذا في ناس اخدين 412 لاب فينا نعمل البروجكت تبع الكورس هيدا واللاب سوا.
صح.
simulation part.
right.
ف يعني هلا امتى لازم نقول لك هالشيء او to take it into consideration مع مس بسمة باللاب؟
Discuss with her and we can talk about it soon. يعني whenever you can كرمال أنت وقتك يعني for your benefit. We can set up
Okay.
short time to discuss. Okay?
Okay, thank you.
Okay, great. Thank you, محدين. طيب, okay, great. لكن last time we discussed the different types of one inverter and we said there are many types of inverters. So we started with the basic resistor-based inverter. And we said that the resistor-based inverter, it comprises of a pull-down device, هذه هي pull-down, which will act as a switch that can connect the output to ground depending if it is on or off, and a load device, which is always connecting the output to VDD. If the switch turns on, okay, then the output will be connected to ground and a short, or it has small resistance compared to RL. And if the switch turns off, then the RL will take care of connecting the output to VDD. فإذا the way this circuit functions is that if the switch is on, this means that my V out will be equal to VOL. And if the switch is off, this means that my V out will be equal to VOH. Okay, and typically with these types of devices where the input is being fed to the pull down device, which is trying to connect the output to ground, okay, our analysis will start with the first step. So first step for the analysis would be to set the device off, the pull down device off, okay, and find what VOH is equal to, which is what we found last time. And then in the second step, we set Vn to be equal to VOH, which is the highest possible achievable voltage, and we solve for VOL. يعني بحط Vn equal VOH, and I check what my output is going to be. Okay, so I set Vn equal to VOH and I solve for the output law. Okay, so these are the steps that we follow typically in solving these circuits. Hello. What we did was we solved last time. We said last time that we found that VOH is equal to VDD. And then we said, well, let me now study the circuit. How would I solve for VOL? Okay, so in order to solve for VOL, okay, what we need to do is we will say that the first thing that I need to do in any analysis is simply, here I have Vn and here I have V out, is to look at the device and see its characteristics. يعني هحط هون I have an NMOS. I want to find what's VGS minus VT. I want to find, well, this should be capital VDS. And I want to determine the region of operation if I am assuming long channel current model. Okay. And for the NMOS, VGS is really nothing but Vn. So this is Vn minus Vt, and VDS is V out. لأنه هيدي الD وهيدي الS. VDD is here, so the voltage here is definitely higher, S is grounded, and the region will be determined based on the point of operation. So if I want VO to be equal to VOL and I'm setting Vn equal to VOH, then this will be VOH minus VT and this will be VOL. And definitely the output low is typically around 0.2 volt. وهيدي VOH is VDD, we said last time. So definitely this will be greater than this. Okay, and therefore since VDS is small or the minimum is VDS, we are operating in the linear region. Okay, طيب حددنا region للNMOS device. هلا to solve I need to set that IR is equal to IN by virtue of KCL. So I will set IR is equal to IN. Okay. and لأنه هيدي is the minimum here, and therefore IR is VDD minus V out, which is VOL over R. It's equal to IN. IN is K prime W by L. فيني استعمل VDS effective بس بدون VDV set. So this is VGS minus VT. It is VOH minus VT times VOL minus VOL squared over 2. So now all of a sudden I have an equation which has second degree in VOL. ليش؟ لأنه أنا I know what my voltages are. VOH I have solved for it. VT I have it. So I have this and this I have. So I'm going to solve for VOL. There are two possible scenarios to solve for this. We either state the assumption that VOL is small. This means that I can approximate VOL squared to be equal to 0. And then the solution becomes linear in VOL, and I can find VOL. Or I solve for the roots, okay? And I pick the root that is positive, and that maintains operation in the linear region. يعني بدي نقي الروت اللي هو positive لأنه VO is positive, and I need to pick the root which is small. إذا ثائب عندي solution هو large فأضلني أنا بالlinear region. Okay, so I need to pick the root that maintains a small value to maintain the linear region. Okay, حدا عنده سؤال؟ طيب great. هيدي ال VOL. We are happy with it. So let us look at another example and follow also the list of regulations which they tell me how to handle. So بهول regulations لكان he told me first solve for VOH. So first he's saying solve for VOH, pardon me. First solve for VOH and sorry هاي ما بعرف كمان second. Okay, so first we are going to solve for sorry VOH, and by applying Vn less than Vtn حليناها هي last time. The pull down is off. Then we apply Vn of VOH and we find VOL, and then we will have Vs. We want to solve for Vs. So we said last time Vs is the point at which VO equal Vn equal Vs. In the case of the long channel model, it is simple. If I want to solve for Vs for the following reason, if I have my circuit now, which is the resistor and my pull down, and I have Vs applied at the input, and I expect that my output will be Vs as well. هلا أنا بحب سميها Vm بس حتى ما تضيعوا بين السورس نود وال Vs. So I'm going to call it Vm, okay? And so I have here Vn and I have here Vn. So again, I'm going to repeat for the NMOS. I will have VGS minus VT and VGS, and we will look at the region. And here VGS minus VT is Vn minus VT, here Vn minus VT, and this is Vn. And definitely this is greater than this, so we are in the saturation region. يعني minimum هو VOV, so we are in the SAT. And لكينا now, if we want to solve for the KCL for the current, I will say IR equal IN MOS. And in this case, it will be VDD minus V out over R, the current. So it will be VDD minus VM مع R is equal. نستعمل general equation. So this will be VM minus VT times, now since it is saturation حتطلع VM minus VT, right? If you forgot the equation, minus VM minus VT all squared over 2, يعني هي حتطلع half K prime W by L times VM minus VT all squared is equal VDD minus VM على R. And now I have a quadratic equation in Vm, and I need to solve for Vm, and of course the solution for Vm has to be greater than VT that دل on the transistor, and the solution for VM has to be smaller than VDD, otherwise it is not realistic. Okay? So this is how we would solve for it if we were to assume the long channel current model for the equations. Okay? Hella, it is simple. In some cases or scenarios, if you don't have the long channel model, then you will compare this and the other one to VDS effective. But I have to give you a hint about the value of VM. يعني ساعتها إذا قلنا أن it is close to VDD over 2 مثلا, then you will know how to compare those values to VDS effective or VDV sat and figure out what is the region and then solve for it. يعني if the model is complex, you either take the assumption and verify if you were a designer, or in the exam we have to give you hints about it. Okay? حدا عنده سؤال عن solving for VM? So this is the third quantity which we solve for. Okay? So we solve for VM, and now we're going to check what are the other three quantities that we have here. So نحن قلنا إنه we solve for VOH, we solve for VOL, we solve for VM, and let us see what is the third quantity. Sorry, كان لازم أشتغل عليها من الأذر. We have to look now at VIL and VIH. And the points VIL and VIH are the points where we have dV out by dV in equal to -1, and the output remains high. هيدي بتمثل لي VIL لما الgain is -1 and when my output is high. And for this point, since the device has already caused a voltage drop, نحن we know إنه VIL is greater than VTN, right? But we also know that the output voltage is still high. Okay, so if we want to look at this region for this specific type of circuit, let us see what happens in the assumptions. Okay, so for the point VIL, I know that VIL is greater than VT, so the device is on, but VGS is small, right? So the device is on, but VGS is small. And I know that Vout is large. Okay, so my Vout is large بعده, and so يعني VDS is also large. بعده ما عمل discharge strongly لأن ال VIL بتجي هون هاي النقطة. Okay, and this is VT. So my VOV is basically small. طيب. يعني if I have the circuit that has the resistor R and the transistor here sitting, and this is Vin or VGS, and this is Vout, okay, the NMOS transistor, if I want to look at its VGS minus VT, its VDS and the region, okay, I'm going to say that VDS is large. So it is not VOH, but it is VOH minus, and sometimes they write it VOH, يعني أصغر منها بشوي. And my VGS minus VT is really VIL minus VT, but this is small. So بأي region I'm operating, this is definitely greater. So I am operating in the saturation. Thank you, Hisham. Saturation region. Thank you, everybody. Okay. Okay. So this is in the saturation region. Great. لكن أنا هلا I will put the equations for IR equal IN, and this is going to tell me that IR is VDD minus Vout over R, and IN is equal to half K prime حتطلع معي if I reduce it W by L times IL minus VT all squared. هلا, and this is two equations, this is one unknown and two unknowns of and one equation, so I cannot solve it. So definitely I need to benefit from the relation that dVO by dVn is equal to -1. Okay, so in accordance with this, what is going to happen is that I'm going to differentiate by dVn in this relation. هيدي شو بصير عندي؟ في d by dVn 0، هيدي بتصير minus dVO by dVn times 1 على r is equal to half k prime w by l times هيدي بدي أعمل differentiation x square بدها تصير 2x 2 times derivative بالنسبة ل Vn حتصير Vn minus VIL minus Vt, right? So this is 2x, right? So dVO by dVn, I know what its value is. It is -1. So I can plug it in here, right? And then I can solve for VIL. لأنه هيدي كلها بتصير +1, right? And I don't know if I solved it correctly. So we find what VIL is. And then of course now if I want to find what VOL, I can plug it back in here and solve for it. Okay? Clear? حدا عنده سؤال؟ So the most important thing is to really know the region in which we are operating. Okay? Great. هلا, this is VIL. The last point which we solve for typically is VIH. Let us at least explore what is the region. يعني نحن بعد ال VIL we start to solve for VIH. So let me see what is the region of operation for VIH. Yeah. So I have my transistor and the resistor connected in this fashion. And when this is VIH, if I inspect the transfer function, I have not yet reached to VOL, but it is somewhere here. So this is VIH, okay, and the output is slightly higher than VOL. So the output is small, it has dropped, and really I am operating far from VT. So I have a large input. So in solving for VIH, I know that my VOV is large. I know that my output or VDS is small, and so practically speaking, if I want to compare VGS minus VT with VDS, chances are going to be this is VIH minus VT, and this is close to VOL, but not exactly. So this will be what? This will be smaller, and the region of operation most probably is going to be in the linear region. Okay, so according to this, I have to set up my equation when IR equal to IN, and it will be VDD minus V out over R is equal to K prime W by L times VIH minus VT, but in here I have VO minus VO squared على 2 لأنه هيدي VDS is equal to VO. Right? So هلا هون I have to explore the relation dVO by dVn equal -1. So I need to differentiate star with respect to Vn, but this is going to be a little bit more involved. When I differentiate it, I will be able to find the value, or I will have two equations, two unknowns, and I can solve for VIH. But what really matters for me is that you are able to classify the region of operation. Okay, لأنه from this equation, if I have some information VOL or VIH, I need to be able to know how to solve for the other quantity, okay, or for the resistor or for stuff like that. So it's very, very important that you know that when solving for the inverter DC, KCL is really what governs here, and that the region of operation based on the transfer function. You don't have to do much guessing. Just know where your point is, build this table, and it will be easy for you. Anybody has any questions?
Professor, how would we differentiate the left side of the equation? We should put
that's here
the current.
differentiation by part, right? Differentiation by part يعني what happens is that أنت عندك تعرف if you have UV, how do you differentiate it? U prime
V plus V prime U.
Right? So it is consuming يعني بس إنه this is the gist of it, okay? So most important for this complex scenario is know at least what the region is, okay? Thank you.
Okay, thank you.
Thanks.
Professor?
Yes.
لما كنا when we were solving for the first two cases ال VOL وال VOH why were we referring to the input as VO also? No, not VI.
Okay. So let me repeat them very briefly. So when we solved for the first scenario, okay, when we solved for the first scenario for VOH, يلي هو لما device is off, I had the input less than VT, يعني فيني حطه 0 for the pull down to be off. To know if this is off, قديش pull up فيه شد, and in case of transistors it will be different. To know how much the pull up or the load can handle the output, right? Okay,
yes.
So I set Vn to 0 and this gives me IR equal to 0 وهيدي عطتني VDD minus V out over R equal to 0, which means V out equal VDD, and this is my VOH, right? Okay. But هلا in the second scenario, when I want to solve for VOL, I need to set Vn to be a high value, right? And the highest achievable on the chip مثل ما حكينا قبل إنه أنا إذا عندي two inverters إذا هاي حطيت لها 0 it will give me VOH وإذا عطيتها VDD it will give me VOL. So from here on inside the circuit, my logic is going to switch between VOH and VOL. Okay?
Yes,
so
yes.
hopefully VOL is less than VTN for this design لحتى لما يفيد ما يدور البول down. That's what I care for. But when we want to apply a high VN, I'm not going to put it VDD, I will put it VOH. Okay? So this is why we said VO. But see, it's an input, you're right. Okay? Clear?
Yes.
Okay. Great.
Yes, thank you.
Thank you. طيب هلا now that we have learned how to handle this circuit, okay, so we will look at other types of designs. يعني we had let us copy this slide here. So we have the resistor-based inverter, but we have other types of inverters. And these other types of inverters can really have a pull-up device, which is an NMOS, and configured in different ways, and we'll see what they are. It can be the complementary inverter, where the PMOS is a pull-up, and it is also capturing the signal. Sorry, أنا مفرز عندي, بس let me check if it is still broadcasting. It's connecting. 1 second. Sorry. Yeah. Let us see. Okay. Yeah, 1 second. We'll be back. Okay. So let me share the screen again. Oh, okay, I need to make myself host. Okay. 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 So basically, I can have different types of pull-up devices. Yeah, if we look at the circuits. Okay, so instead of having the load here, the load can be any other NMOS or PMOS device. Hello. What was this one had VOH equal VDD, which is perfect. It had though VOL different from 0. So we are going to explore different types of combinations where VOL may become 0. And we are going to explore different types of combinations where the resistor, it takes a large area on the chip, so we're going to replace it with a transistor to mimic the resistor. يعني هيدا الترانزستور هون when I connect the gate to drain بصير هو مثل diode connected transistor بصير and it acts as if it is a specific load. So let us first see the first combination where I have a saturated enhancement load يعني حاطة transistor gate connected للdrain, and let us see how this would affect our analysis. Okay, طبعا there's a third combination which is pseudo NMOS inverter that we'll talk about later. So let us now explore the second type of inverters, which is the saturation enhancement load inverter. So now all of a sudden I have my pull down device. Okay, so this is my pull down device. And then at the output, instead of plugging in, instead of plugging in the resistor, I have another NMOS device. And this NMOS device has the gate connected to the drain and they are both at VDD. لأن الهايست اتفقنا بالNMOS هي الدرين. Okay, so هيدي هي VDD. So صار عندي Q أو خلينا نسميه N1 وعندي N2. So I have now N2 and I also have N1, which is the pull down. The input is still being applied here and the output is still being measured here. So لكينا for N-1, so for N1 I have VGS minus VT in all cases. I have VDS and I want to find the region. And then for N2, I have also VGS minus VT. Okay, I have VDS and I have the region for it. طبعا هو هن ل2. Okay, وهيدي هي ل1. Okay, now KCL still holds. يعني for KCL, I still can say that IN2 equals to IN1. So for KCL, I will always say that IN2 equals IN1. And this will depend on the region of operation. طيب great. لكن هلا let us see for if I want to solve for the 5 points that we solved for, and two, in what modes it can operate. هيك لنشوف and two, in what mode it can operate. And two, the gate is connected to the drain. عم يصلني chat. Gate is connected to the drain, so it will operate in the saturation region. صح؟ لأنه VGS minus VT, VGS بيساوي VDS. So for this N2, I have VGS is equal to VDS. يعني this quantity is definitely going to be greater than this quantity. خلينا نشوف what is VGS. It is VDD minus Vout minus VT. هنحطها in general for any case and condition. And VDS هو VDD minus ما هي هاي Vout. So this is VDD minus Vout. So chances are that it is going to operate in what region? It is going to operate in the saturation region. يعني نحن شلنا resistor and we put in its place a transistor, okay, whose gate is connected to the drain, and it would operate in saturation, or it may operate بتكون cut off إذا ما كانت بالsaturation بتكون وصلت على الأوف. طيب for N1 I have VGS1 minus VT, which is what? VGS1 minus VT, which is VN minus VT, and VDS is Vout. Okay, and so the region will depend really on VO and VN and the relation between them. Okay, هلا I'm going to explain to you a little bit about the special case of transistor N2, how it operates. يعني if we look at the transistor N2, and let me ask you those questions. So I have a transistor which is whose gate and drain are connected to VDD. Okay, and let me assume that this transistor, there is a switch and there is a capacitor. Okay, وهيدا switch is open and the capacitor is initially discharged, يعني initially V cap equal to 0 إذا هيدا هو الكاباسيتر. Okay, طيب هيدا لما سكر السويتش. Okay, so when I close the switch, what is going to happen? The NMOS is on لأن عنده حيبلش initially هون على هي النقطة this voltage is 0, so VGS initially is what? VDD, right? So it is going to be on. طيب great, and let us see what is the output node here. هيك لنفكر فيها هيك عملنا what is the output node here. So this is VGS. So here VGS at time t equals 0, it's starting from VDD. Okay, هيدا time t equal t, and this is t equals 0, and this is the time t, and this is node V out or VC. Okay, great. طيب, it will start to send a current. The current is going to charge the capacitor. حيعلى ال V out, حيعلى. هو وعم يعلى ال V out شو عم بيصير بال VGS؟ إذا هيدي صارت VDD over 2 مثلا. شو what is VGS
عم
at this
بينزل.
point? It is now VDD minus VDD over 2. Right? So this is VDD over 2. طيب قد ايه في دلو هيدا يعلي لل VGS at one point? This is going to become VDD minus VT, and this will become what? VT. في دلو يعلى هيدا. Can I keep charging this all the way to VDD?
نو بتطفي
هيدي
هيديك
تنزل للصفر. No. Why؟
بتقول
شو بصير بالترانزستور؟
cut off.
cut off. حيطفي الترانزستور. فإذا هيدا الconfiguration can at most pull up the node to where? To VDD minus VT. اوكي، لانه خلص هو بيطفي الترانزستور. it cannot turn on more. اوكي، فاذا we are going to put a rule that is simple for you to remember, and this rule will help us in this and in the second configuration which is after it. Let us look at this rule. If I have an NMOS device and the NMOS device has a voltage VG and a target voltage VD, and it's trying to pull up. إذا ال NMOS is pulling up node S، إذا اعتبرنا هيدا هو VGG وهيدي VDD with VGG at the gate and VDD at the drain, okay, it can pull up node S, okay, maximum لل VGG minus VT أو لوين، okay, and therefore أنا حوقف عند وين؟ عند المينيموم تاعون VGG minus VT and VDT. هات لنشوف ليش، ناخد couple of examples. Let me repeat it. Okay, let me repeat it. lower limit هي حتوصلنا عنده. يعني أنا إذا عندي مثلا let us say that VT is 0.2 and I have 1 volt here and 1 volt here. The maximum that this can reach is what? هو المينيموم ل 1 minus 0.2 اللي هي 0.8 and 1، يعني حتوصلني لعند ال 0.8 صح؟ right؟ ما فيني جرأ أكتر إنه يكون هيدا 4. ليش؟ لأنه 4 NMOS، لأنه ال NMOS turns off at this value صح؟ اوكي، لأن ال NMOS حيطفي، the NMOS will turn off. هيك لناخد let us take another example. Now what if VGG is 1.5 and VDD is 1 volt. فيني وصل what is VGG minus VT اللي هو عم يخلق لي limit بدفع عليه، هو 1.5 minus 0.2 so 1.3 وهيدي 1. يعني أنا بقدر وصل لكل هيدا الدرين فولتج، بقدر وصلها لل 1 فولت صح؟ يعني أنا I can charge it. ما هو فعليا in real life I'm connecting this to this, but in case VGS is small it is preventing me from reaching my full potential. إذا VGS بتساوي هيدا الفاليو مع ال VT ساعتها أنا I can comfortably reach to this value here. لهيك نحن we say that this is why we say that minimum of VGG minus VT and VDT. فإذا ال NMOS is not a strong pull-up device. يعني أنا إذا عم بستعمل نفس السبلاي فولتج على الجيت والدرين I'm going to be limited. Since we want to use the same VDD on chip, this is the reason why بالCMOS بنستعمل PMOS بالpull up وNMOS بالpull down. Okay, بس أنتو from here on, pardon me, you can use this rule. هيدي خلص as is. Okay, the big picture is it clear? Now it is not going معا to cross 1 لأنه let me explain to you why. It cannot exceed 1 because yeah, in real life what is happening? I have my transistor, okay, this is the gate, this is the drain, and this is what? The source. And the switch is connecting what to what? It is controlled by the gate, but it is connecting the drain to the source. يعني أنا my final value for any node that I am charging is what? Is VDD. Okay, معاً? And so ideally my target is VDD. Okay, but if VGG minus VT is smaller, then I will be limited by it. يعني بيطفي الترانزستور لأنه أنا I want to guarantee إنه the device is on. هيدي الكرايتيريا تاعت VGG minus VT هي إنه the device is on. وعندي target either I switch off early لأنه I violate criteria, or I can reach to this if the criteria is not violated. Depending on the smaller, it will control me. Okay? Clear?
Okay, and can we say that no? I think we can't say, but no. يعني when it reaches VDD, then the current will stop because there would be no
When
voltage
it reaches
drop.
VDD حيصير عندك VDS is equal to 0 صح؟ And practically
VDS
speaking VDS مش هيدا الدرين؟
ما هو في resistor بالأول ولا لا؟
ايه بس what is VDS؟ إذا أنا عندي resistor وعندي الدرين والسورس and هيدي VDD صارت وهيدي VDD, what is VDS؟
ايه بس انا فكرت انه مش الدي هو VDD يعني above
ايه
the
let me
resistor.
clear it let me clear it لا let me clear it one second. Okay, let me draw it clearly. So here we have the transistor هو عبارة عن resistor variable and this is VDD. Okay, and this is the D node. Okay, so either if VDS equals 0 خلص مجبور الكرنت طفى صار 0 صح؟ Right? إذا approximated it to a resistor, right? مش إذا ال VDS إذا ال S صارت قد ال D مش بتصير 0 ال VDS؟
Yes.
Okay, so if VDS equals 0 خلاص no more current طفى I can no longer charge it صح؟
Yes.
Okay, or if VGS becomes less than VT كمان الكرنت راح طفى. So two scenarios and we will see them يعني ال IDS بتصير 0 بعد حنمرق فيها هاي نشرح كيف بيكون linear. Okay, but this is the gist of it. If you think of it as a resistor الكرنت حيصير 0 or الكرنت حيصير 0 من ورا VGS minus VT is violated. Okay, يعني it turns off for two reasons. يما ال S وصلت لل D يما ال VGS صارت أصغر من VT. Okay?
Okay, thank you very much.
Okay, you're welcome. So نحن فينا ناخدها على high level ونقول either I can reach VDD or I can reach VGG minus VT. Anybody has any other questions? طيب okay. Okay. So لكينا هلا now that we know this we can go back to our circuit, okay, which looks like this and start to study the different cases and conditions of operation. Okay, so now we can study case number 1, which is the case for VOH. Okay, so if we want to study the case for VOH, what we have here is I will set my VN to be 0 لأطفي ال pull down device. Okay, and if I set my VN to be 0, this will be off. Okay, and this device will be, the output should be VOH. Okay, so the output will be VOH, and really here I will have VDD minus VOH, and this will be VDD minus VOH minus VT. Okay, so for this one, for this special case, what I end up with is I end up with IN2 is equal to 0. But really, I will end up with a scenario where I have this connected to VDD like this. And we are trying what is the DC value for V out. And we can guess it directly from the rule. لأنه هو in saturation. Okay, and we can find that إذا بدكم تحلوها من saturation half K prime W by L times V GS minus VT VDD minus V out minus VT all square equal 0 بيطلع عنا ال V out هو VDD minus VT. اوكي بس this is more like empirical انه ايمتى الكارنت حيصير 0 حيصير الكارنت بيساوي 0 لما هيدا يشرج ال V out لهيدا الفاليو or directly we can say well there is nothing here there is open and this will be the minimum of VDD and VDD minus VT so it is VDD minus VT. Okay clear يعني this NMOS can maximum charge my output ما بقى عم بطلع على ال VDD